So, I've got a ball. I've got the air source. Of course, there is kind of nothing special about this situation. You have a force pushing up, so strong enough to compensate gravity. But this situation is strange, right? Why it doesn't fall? Well, turns out Bernoulli's equation explained this. This airflow travels differently above and below. Here it's easier, here it's harder to travel, more obstruction, so here it travels slower, and because it travels slower, it exerts more pressure, so high pressure pushes up, low pressure pushes down, but higher is stronger, actually strong enough to compensate gravity and pressure from above. So, because of the difference between how airflow flows above and below, it hangs, it's suspended in air. Here, I've got a golf ball, heavy ball. Why didn't it fall? Well, again, this ball makes air shadow below it. So the airflow above is fast and below is slow. Lower speed, higher pressure. So the pressure actually from above is so strong that compensate the pressure from below is so strong that compensate the pressure from above and force of gravity. Well, and I've got an experiment similar to my first experiment, but much more convincing. This is my ball. And this is the air source. The leaf blower. I was able to hold it at almost 45 degrees. Why? Again, because of the same reason. The speed of the airflow above the ball was very, very high, but the speed of the airflow below the ball was so low that the pressure from below was so strong, exerts so strong force, sufficient to keep it in the air. Are there any practical applications of this theory? Of course. That's why airplanes fly. The wind is like that ball, essentially. And the airflow below the wing has a low speed, so the air pressure is so strong enough to lift so heavy machinery and make it move. Well, this is another practical application. Fountain. Let's have more fun. What do I need? I need again, first I want to switch to see it. Now I need to lower it. Now I need to mute it. So many actions. Why? No one created one uniform control device. Because no one really cared about providing good remote lectures. If people cared, I mean, didn't say they cared, but they really cared, they would have been doing something about that, and maybe now they will. So, I want to steal a gasoline from a car of my neighbor. I never do that. It's a joke. I need to move this water from here to here. So first, I'm gonna place this end of the hose here, and now I'm gonna place this in the beaker, and what's gonna happen? Nothing gonna happen. Why would it happen? In order to make this liquid, fluid, water move, I have to make a pressure difference. Well, first I could suck the air out, the water would be moving, and then I'll let it go. Also, I can try to do it differently. I can first fill this up completely, this hose completely with water. Okay, Python. And now, see, now it travels down. And of course, if I flip it, I make a fountain, tiny fountain. Why is it tiny? Well, theoretically, in an ideal situation with no friction, according to the law of conservation of energy, that water would have been shooting to the original initial level of water in this bucket. But of course, nothing is really ideal, there is some friction. So in reality, without an additional pumping, it never reaches the original height, but with the extra pumping, of course, it could go even higher. So this is a siphon This is a fountain.